Here's the last example from chapter 29, and these get kind of long. This is example 7, so I'll try to run through this a little quicker. The main thing is this question, without me reading everything, is we're talking about small baskets and large baskets. So X will represent the number of small baskets. Y represents the number of large baskets made. So this is all about the baskets being made. So we have our type, small, large. Some people reorder this, and I always put the variable right beside it. So we have number of baskets. X, Y. Chalk for chocolate. Balloons. And roses. So a small basket has 5 chocolates, 1 balloon, and 12 roses. A large basket, 10 chocolates, 6 balloons. My page is kind of blurry. And 12 roses. And its price is 20 for a small, 40 for a large. So we want to maximize our income. So what we want to maximize is 20x plus 40y. So right here, that's where our max comes from. As soon as it's price, cost, whatever, that's our max, min, whatever the question is. But this time we want the biggest number. So now chocolate, the shop has access to 80 chocolates. So the chocolates here, they have access to 36 balloons and 168 roses. So that's where our equations come, or inequalities, constraints come from. First two, x greater than or equal to 0, y greater than or equal to 0. Then I go to my chocolate equation, 5x plus 10y has to be less than or equal to 80. We're going to divide that by 5 and we get x plus 2y equals 16. It is less than or equal to 16. Our next equation, x plus 6y, has to be less than or equal to 36. We don't have to shrink that one. It's already down to where we want it. X plus 6y, less than or equal to 36. Then our third one, 10x, no, what am I doing? 12x plus 12y less than or equal to 168. We're going to divide by 14. X plus y is less than or equal to, or we divided by 12, sorry, gives us 14. I had 14 in my head. So now we have our 5 constraints to graph. Those two, these 3. Here's my x, my y, and this would be considered my x is greater than or equal to 0, y greater than or equal to 0. Now we'll do x plus 2y less than or equal to 16. X is 16, y is 8. So there. Connect it. X plus 6y is less than or equal to 36. Well, x is 36. I'm not getting that on my graph, but y is 6. And my slope is negative 1 over 6. I can do that with a little quick algebra. This becomes y equals negative 1 over 6 plus x plus 6. So I'm going to go down 1 over 6. Gives me a point right there. Imagine that. If it was drawn well, that would connect. So then I do that. This is equation 3. 3, 4, 4. Now equation 5, x plus y is 14, 14, 14. So now I get a point of intersection here. So where these lines meet, and I want this as my feasible region down in here. So I've got this point at 6 and 5. This one, 0, 6. So I'll start writing them in. 0, 6. 6, 5. Here, if this was drawn well, that would be 12 and 3. I have 14 and 0, and 0, 0. 0, 0 matters because maybe it costs too much to make the products and they'd be better off not making any. It does happen in some cases. So now I've got my 20x plus 40y. 0 times 20, 0, 40 times 6, 240. That one's 0. 120 plus 200, 320. 240 plus 120, 360. Is that right? What am I doing wrong? 12 times 240. Oh, that's 12 and 2. And 80, that's 320. And then 280. Okay, so the max income they can make from this is a tie. It's either going to be this point or this point. Max income will occur at 6, 5 or 12, 2. Now, because we have the tie there, these 2 points will also maximize profit. So they also will have it at 8, 4 and 10, 3. Would I expect you to be able to come up with those 2 points? No. I would expect your answer to be those 2. And I wouldn't even look for the other 2 in most cases. But you would have the option. So you go 6 small, 5 large, or 12 small, 2 large, plus the other 2 possibilities.